it's now time to get the ball rolling for our next speaker in the house. He's the author of the award-winning bestseller, The DevOps Adoption Playbook and DevOps for Dummies. Our expert is currently serving as the Senior Vice President, Head of Automation and Platform Engineering at Truist. Through his talk, he's going to draw your attention towards the concept of observability and why this matters today more than ever, especially for complex cloud-native systems. If there's anyone you want to be in the orbit of, it's none other than Mr. Sanjeev Sharma. Hitting your screens right now.
Hey, good morning, good evening, good afternoon, good night, wherever you might be around the world watching this presentation. Welcome to my session at DevOps India Summit. It's always a pleasure to be a part of this wonderful event put together by Niladri and his team. And this is, I think I've presented every year, so very excited about it. And I would like to thank the organizing committee again for including me. So what are we talking about today, right? We are talking about observability, right? That's been the new buzzword that has been going around, especially in the cloud native world for the last few years. And it is also, like any new buzzword that comes up, fairly misunderstood, right? So this is my perspective. That doesn't mean it is the perspective. I'm going to give you my perspective today and talk about why everybody should be looking very serious at observability if you are building and deploying and operating cloud native applications. And we'll talk about why, and we'll talk about what is observability, at least as I said, my perspective of it, and why does everybody need to pay attention to it. So let's jump right in. Right. First of all, let's talk about, who am I? Right. So I've been around in the DevOps world. I've been around for a long time, as you can see from my gray hair. I have, as I joke with people, I've been around for several versions of Linux. And along the way, I've done some work in the DevOps field. I used to work for IBM, where I was global CTO for DevOps. And during that time, I wrote 2 books. They are my claim to fame. I wrote the original DevOps for Dummies, the IBM limited edition. It's a thin 70, 80 page version. I wrote 2 editions of it. And it's still available for download from ibm.com. So you can Google it and get it. It's free. And it's an easy read. It's the book you give to your boss when he or she starts asking you questions about DevOps. That's the joke, guys. I'm not telling you to call your boss a dummy. The book you should read, if you are here actually attending this event, if you haven't read it, and want to learn about how to adopt and scale DevOps, is the second book I wrote called the DevOps Adoption Playbook. I wrote it back in 2015, 2016, took me a while to write it, but it's still relevant today. I tried to stay away from any implementation technologies and focus mostly on principles and various scenarios. This is based on over 100 client engagements I'd been involved in when I was back at IBM, helping large organizations and small organizations adopt and scale DevOps. So that's, I recommend if you are here, this event, watching me, listening to other speakers, you need to read this book. Again, that was the end of my commercial break. You can also follow me on my blog. It's SD Architect, like software delivery architect.blog. I've been writing that for well over a decade, or many versions of Linux, as I say. And I write on a broad topic. If you're going there just for DevOps content, you won't, you'll have to go back a couple of years. It's my blog. It's my opinion. I write about whatever I feel like writing about. I think at the time of recording this, the last blog post I wrote out was on blockchain, right? And Web3. So if you want to learn about my perspective on that, feel free to follow along. What will I be writing about next? I have no idea. I have like 20 open blog posts. I have drafts I've been writing. One of them will probably make it to the website, but stay tuned. So I've been around for a while. And today, as I mentioned, I'm going to be talking about observability. This is kind of the agenda. This is not a very long, deep dive technical talk. If you want that, I can point you to a few sources which I actually refer to during my presentation. So we'll talk about what is observability by talking about what observability is not, right? Then we'll talk a little bit about why observability is a challenge in the cloud native world, especially, right? Because cloud native world is extremely complex and has a level of complexity which far exceeds what we can get from, quite frankly, human comprehension, in my opinion. And so we need a lot of automation, right? And we can go into AI ops and other capabilities, but to keep the context narrow and give it the treatment I have in the 30 odd minutes I have to talk about it, I'm not going into implementation details, but more about the why and the what, right? Not the how. And there are several people who are much better at this than I am, who I can point to. And I refer to them, as I said, throughout the presentation. So you hear some names and see some quotes, and those are the people you go to if you want to talk about the how you want to implement it, right? So let's just jump right in. And I want to leave a couple of minutes at the end for Q&A. So feel free to engage with me via the chat, and of course on Twitter. I'll publish these slides, so you'll have my Twitter ID and contact information goes on the first slide. So what is observability not? Well, first of all, why is that O11Y in there? Well, that's how people shorten observability, right? That's the new cool thing, I guess, the kids do, is shorten words, right? Those of you in India are probably familiar with this, right? We have acronyms for every movie name, which is long, from DDLJ to whatever the latest movie is. So, well, in the tech world, we have been shortening words by putting a number in the middle, which is a count of the number of characters which we are replacing, right? So observability becomes O11Y. Don't ask why, but it's a long story. Maybe we can talk about it some other time. So what is observability? Well, it is not monitoring or telemetry, right? So I went to the source I usually go to see what the world thinks observability is, and I found this reference in Wikipedia, right? So let me read it. I hate reading slides, but in this case I have to read it because this is important that we pay attention to every word here. So observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. That's very interesting, right? If you look at it, when you go to a doctor, the doctor is doing this to you, right? Unless there's invasive, colonoscopy or something going on, the doctor is looking at external outputs, right? Temperature, blood pressure, your eye color, or when it shines, she or she shines a flashlight into your eyes, how your reflexes work, what your heart rate is, how your breathing is. These are all external outputs by which the doctor is trying to infer the internal state of a system. So the term observability, as you see in the second paragraph, comes from the control systems, right? Of a controllability of a linear system. And, there's a mathematical concepts around it. And it's not new. The term observability and these concepts were introduced a long time ago. I think I did not include the date, but these are not new concepts which came up. We are in the IT industry, in the technology industry, are just beginning to use them in the technology world. Now I switch you over to the right side of this slide, where we have a quote from Charity Measures, who is the founder of Honeycomb. And she was the one where I found had the best description of observability, which I could find, right? And this is her tweet responding to somebody quoting her, right? So anyway, you can go look this up. But she says, here's the definition of observability, right? Can you understand whatever internal state the system has gotten itself into just by interrogating and inspecting the output, even if you have never seen it happen before? The last part is very important. In fact, we'll dissect this whole, and then try to digest this whole quote from Charity, right? And I wrote an entire blog post on this. In fact, this presentation is nothing but a presentation based on that one blog post I wrote a couple of years ago. Of course, updated for current understanding. So let's dissect and digest Charity's statement. And if you look at the first statement, right, can you understand whatever internal state the system has gotten itself into? Yeah, I mean, if you look at the definition from Wikipedia, right, from the mathematical definition, the control systems definition, it is exactly the same. Can I measure how well an internal state of a system can be inferred by looking at its external output? So the first statement is pretty much the same. Can I understand whatever internal state the system has gotten itself into, right? And part two says by inspecting it and interrogating its output. So what people keep confusing about, and a lot of vendors who I shall not name to protect the guilty, have been doing is talking about their monitoring and telemetry tools and say, that's observability. Well, is it, right? So let's dissect that, right? Let's look at statement one. Can you understand whatever internal state the system has gotten itself into? By the way, there's a nuance in this statement, which is very important. Whatever internal state the system has gotten itself into. Why is that important? Because complex systems, IT systems, large systems, get themselves, and even small systems which are complex inherently, get themselves into states that we do not know how they got there, right? And, if you look at it, hey, I wrote the program well, these systems aren't supposed to behave the way they are. How did it reach this state, whether it's in an infinite loop or whether it's like burning up memory like it's free or, burning up storage? how did it get into this state, right? And hopefully I'll have time to give you some examples of these scenarios, right? But how did it get into, right? And if I have good telemetry at the system level and at the individual components of the system, I should be able to understand what state the system is at just by interrogating its output, part 2 of the statement, right? Now that's interesting, just by inspecting logs. Yes, logs are output. We know them. And outputs we are getting, right? So if I can interrogate where the disk is being written, what is being written, I can see, okay, why is my storage getting filled up so fast? But this is where it becomes a bit interesting, which is the last statement, which is especially if you have never seen it before, right? That is a problem, because if you look at monitoring systems, traditional monitoring and telemetry systems, and looking at logs, all my monitoring is based on what I determined needs to be monitored. And usually, based on my experience, I would have probably designed those logs and the systems to be monitored in a manner, and the dashboards that I'm looking at my single pane of glass to look at the state of the system is telling me the metrics and the information I need based on what I think could go wrong beforehand. That means everything I have designed in my monitoring regime is designed to help me identify problems that I have either seen before or at least thought of before. If it's a brand new system, I might not have seen it in this system, but my experience tells me these are the kind of things that could go wrong in this system. What happens when something goes wrong, which I have never seen before, right? How do I then figure out what should have been monitored and what I wanted to see in my dashboards, right? Yeah, I had this conversation recently with somebody where I work currently, and they were saying, all that data is in the logs. Yeah, but how do you pour through those megabytes or gigabytes of logs and correlate the various logs? That's the problem usually. How do I correlate them to figure out A happened here, B happened here, C happened here, Q happened here? All that means something else is a problem if I've never seen the problem before. I do not know what to look for. That's where observability comes into play. And this is a very key distinction between monitoring and telemetry. So when the next vendor comes you, which is selling you a monitoring solution or a telemetry solution, you need to ask them, how do I, in your system, understand a problem if I've never seen it before and I did not design your system in order to be looking for that? That's where observability becomes very critical, right? So here's a difference, right? So on the left, you have I believe that's an F-35 dashboard. I don't know, maybe it's classified, maybe it's F-22. Who cares? It's a fighter jet dashboard. That dashboard is giving a pilot all the information he or she needs in order to fly the plane. On the left, it seems like it's showing some weapons, right? If you haven't seen, go see Top Gun Maverick and you'll see what this is all about, right? And you'll see some fun flying and some fun, shooting, by the way. Best movie ever made, which involved fighter jets. Much better than the original Top Gun, but I digress. On the right side is a movie which is totally fictional. Iron Man is not real, despite what people might believe. But in that, there is a scenario in Iron Man, and hopefully you've seen the movie Iron Man 3, and I'm not spoiling it for you. But some people start falling out of Air Force One, which is the US president's plane, which has just been blown up, and there are people falling. And Tony is asking the question to Jarvis, which is the AI which runs his suit, the Iron Man suit, and saying, how many people have fallen out of Air Force One? And he says, Jarvis responds, there are 13. Okay, Jarvis can count, we get that. And he has, radar system or whatever, sonar system, which can tell him how many people are humans falling through the air. And then he asks, how many can I carry? 4, sir, right? So he has done some math here, Jarvis, about the fuel Iron Man has, about, well, I don't know if he has fuel, but he has some kind of a nuclear reactor in his chest, about the force he can carry, about the weight of these 13 people, the height there is, the velocity they're falling back, and he somehow calculates that he can carry 4 people at a time. But as you can see in the picture, eventually it's a happy story. Spoiler alert, he rescues all 13 of them. Now, telemetry versus observability. The fighter jet pilot on the left-hand side of the screen has telemetry. That means he can answer questions like, how many missiles do I have left? Or can I, at this speed, shoot that 1 by 1 meter entrance to the weapons depot, which I need to blow up from this altitude at this speed, moving at, this many Gs, and then turning as I'm shooting it down. The telemetry can answer those questions. It can also say, hey, my aircraft carrier is, 100 kilometers out. It is moving at this speed. I have this much fuel left. This is the wind drift. These are known problems the Air Force pilot, the fighter pilot can face while flying. And all this data which you see as all this telemetry and monitoring information which is available to the fighter jet pilot is to answer all those known questions, right? Which are known problems which a fighter jet, the finite set of problems which a fighter jet pilot can face while he or she is flying. Observability in this fictional scenario is Tony answering a question which none of them have ever seen before, which is Air Force One has blown up, 13 people have fallen out of the sky. How many can I save, right? And it's a scenario where you need observability. You need to be able to look across all the data coming in from all your monitoring systems, know your internal state, which is, the suit which Iron Man has, what all is available, how many thrusters, how much force can the thruster exert, what is my height, how fast can I go down and pick up those people, what's the total weight, and how much time will I have left to do that? Well, that's observability. That is answering a question which you have never thought of before. That's the key distinction between telemetry and observability, right? So going back to Charity, she's, I guess my source of information around observability, right? How does one do observability, right? And let me read this. It requires methodical, iterative exploration of the evidence. What's the evidence here? All the data coming in from a logging and monitoring, right? That's the evidence. That everything you have, that you can't use your gut and a dashboard to lead to a conclusion. Well, which is what I was talking about earlier, right? My dashboards or my gut feeling saying, hey, that router always goes out, at 9 a.m. in the morning for some reason. Well, that's my gut telling me that could be the problem, but I'm guessing, right? And then I have to go through a process of elimination to get to a conclusion. Or I look at a dashboard and it says, storage red, memory red. Well, it must be Y. That must be the reason. But systems today are too complicated and they're too unpredictable, right? Your gut, if it is based on a traditional system, not a cloud native system, or on your system you worked with in the past, where you got your experience from, not have the complexity, right, of what the current system has, you cannot use your gut. Secondly, our experience, and around a year and a half ago when I joined my current job, I went and read every open ticket that had been resolved and its root cause analysis from the prior 2 years, 140 something tickets, right? I didn't read all of them. I just read the high priority ones and I obviously didn't read the ones which did not have a complete RCA. That gave me a lot of experience about where the instability was in our system, which we were responsible for, right? And then we could go fix those problems which had happened to ensure they don't happen again. But what do we see from going forward? Did the system become 100% stable? Did we get, 9 nines availability? Of course not, right? We improved the availability, but the outages that happen today should be different from outages that happened in the past. That's good work. That's good, hygiene, where you learn from the previous outages and lack of, and loss of, a lot of system information. And then what you go and do is make sure that those same errors don't happen due to the same root causes. Either you get new errors or you get the same errors, but due to different causes. But that you cannot predict, which means your current system of dashboards and monitoring and telemetry are not going to help you. That's why you need observability, because now you have to analyze and solve for issues that have never happened before, that you've never seen before, or have been caused by different reasons from what you might have seen before. Now, all this was fine. Why do we need observability now? We've been running systems for decades and they run pretty fine. Planes are flying, fighter jets are flying. We still haven't invented Iron Man, but we still have pretty complex systems which run, right? If I'm recording this right now, I'm in one continent. Most of you watching are probably in another continent. It's working, right? Which means systems work. Why do we need it? Well, because cloud native applications are more complex, right? Now, what is a cloud native application, right? And I'm not going to read this, but you can go. This is the CNCF version 1.0 definition of cloud native. And essentially, it is a new way to develop applications that are designed specifically for the cloud so that they can be resilient, manageable, and observable while being loosely coupled and minimize the toil. So, the need for observability is kind of built into the definition of cloud native if you pay attention to it. But let's go into what it is, right? The challenge, cloud native is not one thing, by the way, right? It isn't, we've got the 12-factor application, which goes around microservices. We've got containers coming. We have serverless. But there are core components of cloud native, which is you're using 12-factor architectures, so microservices. You're using containers or serverless. you're doing continuous delivery, and then you have real-time orchestration of the complex system as it is running, right? And systems in cloud-native world are getting more and more complex, where you had 2,000 virtual machines, right, which maybe you had running on the system, and maybe you had a very dynamic system, so those virtual machines could be horizontally scaled and vertically scaled based on what the needs of your system were. But in the container world, or in the serverless world, and truly in the cloud native world, that complexity goes much higher, right? Because the number of instances of what you're running is ordered by several order of magnitudes. And secondly, you are not running all of them. Unless you have a full stack private cloud where you control every bit of it. If you're running in a public cloud, if you're running in a true, where you're using cloud managed services, all the services you need are not provided by you. That means you're dependent upon the availability and the reliability and the SLAs of several other services which you do not have control over. That increases the complexity even further, right? So complexity gets real. On the left-hand side, you're seeing the architecture of Uber back in 2018. Hopefully it's less complex now. Maybe it's more complex now. I do not know, but this is what they published back then, right? These are all the microservices that run when you access the Uber system. This is what's running globally. And there are probably several instances of running around the globe. On the right-hand side, right, if you see, observability, the monolithic architecture, which had, multiple tiers talking to a database, go to a UI talking to multiple tiers broken down into microservices, talking where each microservice might have its own database or data store, which is a better word to describe it. So you have to now keep track of all of that, right? Think if Uber was built with VMs, do you think it would be that many instances of these are probably all containers or serverless functions running, right? It would be much, much less complex, but it obviously wouldn't have all the resilience and all, right? Now, if some of you are like me, you're an architect, you're probably seeing some of those anti-patterns in there, right? By looking at it graphically, like what's this big blob in the middle, Death Star pattern in the middle, which, a lot of things seem to talk to, but I digress. Coming back to the microservices piece, and there's a quote there that we have to manage more services and instances than we had ever seen before, right? And it is beyond our ability, right? You cannot have a graph now of every container's performance. That's not possible. Can you have a dashboard with that? It'll be crazy, right? So you have to go to the next level of abstraction, which says, I cannot be looking at everything at every time, but I need my system to be accessible enough and queryable, if that's a word, enough that I can go and make the kind of query I need to when I need to, based on what I am seeing, right? So I have health checks. I don't need to be looking at every health check, but if some health check is failing or some SLI is being breached, is acting weird, I should be able to create queries on the fly and be able to understand the problem, whether or not I've seen it before, right? And that complexity of cloud native requires me to do that, which means the world is getting more and more complex, which is why traditional monitoring and telemetry is not going to work. What you really need is what my friend Tobias Kunze from Glassnostic calls air traffic control, right? Which he refers to as the new operate, right? So let's read this. This is from a blog, Tobias, my good buddy, and he is CEO of a company called Glassnostic. Check it out. Pretty cool stuff, right? He talks about, right, we need to acknowledge that today's cloud native architectures are unstable. Why are they unstable? Because they are unpredictable, right? As I said, they are complex, right? Which means an instability in one part of my architecture how it will impact another part of the architecture, I do not know. How if a failing service or system from a third-party system, right, can result in instability elsewhere, I cannot predict that, right? So, which means there's nothing we can do to prevent instability. If you go back to chaos engineering, you'll see some echoes of chaos engineering here, but they must be controlled, right? Which means you have to assume that there is chaos in your system and things you could not predict are going to happen. Your goal is not to prevent them because you cannot prevent everything. Your goal is to control them, right? So there are 4 things, according to Tobias, that you need to do. One is observe what is going on. That's what observability is all about. And then he talks about, which I'm not going to be able to go into in interest of time, talk about how do you remediate sudden degradations and what he calls, black ravens, without having to even figure out a root cause analysis at that time, right? The first thing you need to do is fix what's happening. And then later on, you can go figure out the root cause to prevent it from happening again. and actively create predictability by automating that, right? That's where AI ops and proactive policies come into place to say unpredictable, crazy things are going to happen to my system. We humans cannot react fast enough. How do we automate that, right? And then while do that all while managing costs, right? An incident for which you might need observability might not be just an outage, might not be just lack of performance or availability. It could be my system got too expensive, right? I'm having spiking costs. How do I address that, right? In fact, one of the policies I have in the past at organizations where I worked has said any cost overage by a certain percentage should be treated like an incident. Give it an incident number, do a root cause analysis so we can figure out why it doesn't happen again, how it doesn't, what we can do to make sure it doesn't happen again. Or maybe the cost is justified because we just got way too many customers. Then you don't need an incident. But if a cost happened because something was wrong in my architecture or something was wrong in the performance or behavior of a service I was running, then we need to make sure we treat it like an incident, do the root cause analysis, but we first need to observe it. What happens with cost usually is if you're not doing real-time observability of cost, you find out 2 months later when you get the bill from AWS, right? And that's when you're pulling your hair out, figuring out what to do. But I digress on the cost issue. It's just important to know that observability is not just about performance and outages. It is also about cost. And I'm so glad Tobias mentions that. So I leave you with this quote, right? And this is again from my friend, is all systems are finite, especially if you pretend they are not. We need observability because systems are finite, because systems are going, in reality, systems resources are finite, right? Yeah, even if you're running in a public cloud, at the end of the day, everything is finite. Even if you have the whole region to yourself, which is never going to happen, and you can scale infinitely in the region, obviously not infinitely. At some point, even a public cloud will run out. The money you can spend to scale is definitely not infinite, right? It is finite. So if you pretend that your resources are not finite, you're definitely going to run into trouble. So in conclusion, right, the new operate means that systems have gotten way too complex for us to handle them traditionally. And in order to handle them in the new way, to operate them in a new way, and to react the way we need to for unpredictable, unexpected behaviors, we need observability. The traditional telemetry and monitoring systems are not going to work. You need true observability where you have the level of dimension, the high dimensionality you need to be able to run queries, to understand situations and behavior which you have never seen before and which you cannot do an immediate root cause analysis on, right? Well, that's all I had, folks. Hopefully this made sense. With that, I'll pause and open it up for questions.